Assalamualaikum warahmatullahi wabarakatuh. My name is Untitled. We are from Group 5. So today, my friends and I are going to explain on how to solve the given problem by using QR factorization manually and by Mathematica.
Assalamualaikum. So my name is Saidatina binti Muhammad Azam. So today in this part I will tell you about QR factorization by using manual. So the question is solve x using QR factorization by A 4 by 3 matrix and B 4 by 1 matrix. So, find the orthogonal basis by using Gram-Schmidt process for column A span 2743, 6858, 9637. So, to find the orthogonal basis, this is the formula. This is the step by step. So, let x1, x2, x3 be a basis. V2, V3 as follows. So V1 equal to x1, V2 equal to x minus x2 times V1 per V1 times V1 and multiple by V1. So for V3 is x3 minus x3 times x V1 fraction V1 times V1 and multiple by V1 and x3 times V2 fraction V2 times x2 and multiple by V2. So from the formula that before this, we substitute the equation in the formula. So V1 equal to x1. So the column 1 is 2743 and V2 equal to the so calculate and we can get the answer. So for V2 multiple and then this is the final answer for V2. So it same goes for vector 3 equal to V3 minus V3 times V1 fraction V1 times V1 multiplied by V1 minus V3 times V2 fraction V2 times V2 and multiple by V2 and the final answer for V3 is this one. So in this part, we will learn how to find orthogonal basis by using orthogonal basis that we had calculated. So the formula of orthogonal is vector over orthogonal basis. So we substitute the data and we can get the final answer for U1, U2, and U3. So we substitute the data and calculate to find the final answer. So that's all from me. We had learned how to find the orthogonal and from the orthogonal basis we can find the orthonormal basis.
Assalamualaikum. My name is Untitled. So I'm going to continue from the previous slide that had been presented by my friend. So the fact that Q has orthogonal columns can be stated as Q transpose times Q is equals to identity matrix. So in particular, Q has a left inverse and D as Q transpose. From this, we can find R, where R is an invertible upper triangular matrix. So A can be factorized as A is equals to QR, where Q is orthogonal columns and R is the invertible upper triangular matrix. So move Q to the other side to find the R. So we have Q inverse times A is equals to R. Q inverse is equals to Q transpose. So Q transpose A is equals to R. So we're going to find Q transpose and then multiply it by A and we will get the R. So this is our Q from the Gram-Schmidt process. So as we can see, this is a 4 by 3 matrix. If we're going to transpose it, it will be 3 by 4 matrix. The rows and columns will change. So this is our Q transpose. The Q inverse is equals to Q transpose As we can see, the rows and the columns are changed. As we get the Q transpose, we can now find the R. So Q transpose times A, and we will get the R. So this is the Q transpose, and this one is the matrix A, and this is the answer for the matrix R. Suppose A is an m by n matrix, which is m by n matrix with m is larger than n, whose n columns are linearly independent. Then the least squares solution of the linear system AX is equals to B is given by X is equals to R inverse times Q transpose times B, where Q and R are the matrices obtained from QR factorization of A. So to solve X, we must obtain R inverse. So we must recall back on how to find the inverse matrix. So for this problem, to get the R inverse, determinants and cofactors are involved. From this matrix R, we're going to find R inverse. The first step while finding the inverse matrix is to check whether the given matrix is invertible. For this, we need to calculate the determinant of the given matrix. If the determinant is not equal to 0, then it is an invertible matrix, otherwise not. If it is invertible, proceed to the next step. So we must get the determinant R not equal to 0. So this one I choose from the row 3 from matrix R. So this is our determinant R. Determinant R is equals to 139.50986, which is not equal to 0. This means the matrix is invertible. Now we have to find the determinants of each and every 2 by 2 minor matrices. So to create the adjoint or the adjugated matrix, reverse the sign of the alternating terms. So we have the positive, negative, positive, negative, positive, negative, and a positive, negative, positive. So just calculate it by calculator, and we will get a new matrix R form. This is the new matrix R. And then take the transpose of the obtained cofactor matrix to get the adjugate matrix. So this is our adjugate matrix. Substitute the value of determinant R and the adjugate R in the formula to find the inverse matrix of R. So this is 1 over determinant times adjugate matrix. So this is 1 over determinant R times adjugate R. So this is our inverse matrix of R. As we get the R inverse, now we can solve for X given by X is equals to R inverse times Q transpose times B. So this is our R inverse. This is the Q transpose, and this is the vector B. So solve one by one by multiplying the Q transpose and B, and then from the answer we can multiply it with the R inverse. So this is the last answer for the values of X. So for X1, 1.51988, X2, negative 1.10845, and X3, 1.07092.
Assalamualaikum, my name is Norfika Asim. So me and Fatiha will continue to explain about the Gram-Schmidt and QR factorization by using Mathematica. So the first question is, by using Gram-Schmidt, find the orthogonal basis and after that orthonormal basis for column. So given the matrix A, which is there are 3 vectors, which is the first vector from column 1 and second vector from column 2 and the third vector from column 3. So by using Gram-Schmidt in Mathematica, we need to input a command which is orthogonalize. So the first vector 2743, the second vector 6858, and the third vector 9, 6, 3, and 7. And we execute the command, automatically we will get the output for the orthonormal basis by using Gram-Schmidt. And there will be U1, U2, and U3. So this is the autonomous basis by using Gram-Schmidt in Mathematica. Next, by using QR factorization in Mathematica, we need to solve x using QR factorization given by matrix A and vector B. So for QR factorization in Mathematica, the first one we need to input is a vector B, and after that QT, which is Q transpose R, equal to QR decomposition and matrix A, which is we write here M equal to matrix A based on the question. Next, after we input the command, the output will come out vector B, and after that we will get Q transpose and R. So this is Q transpose and this is R. As we can see here, Q transpose is the same output that we will get from the Gram-Schmidt. So it is the same. But the difference is the command that we input in the Mathematica. So this is to get the autonomous basis by using Gram-Schmidt. But for the QR factorization, we need to input the Q transpose and QR decomposition. So this is the command to get the autonomous basis by using QR decomposition. So this is the first command we need to input in the Mathematica to find the solution of x by using QR factorization.
Hello, my name is Nur Fatih binti Muhammad Fadli, and I will continue the explanation of QR factorization by using Mathematica software. Okay, so we insert the input of Q transpose to get the output in the matrix form. So as you can see, matrix form that is given by from the Q transpose is in 4x3 matrix. Then we insert input R also to get the output in the matrix form, and the output given is in 3x3 matrix. And then we want to get the value of x. We insert input x equal to inverse R multiply with QT and multiply with B. And here as you can see, we get the true value of x, which is 29,581 over 19,463 and negative 21,574 over 19,463 and 20,844 over 19,463. Now we insert the input of map in the matrix form of Q transpose and R to combine matrix of Q transpose and matrix of R into one matrix. Okay, so as you can see here, this is the matrix form of Q transpose and this is the matrix form of R. So to get the value of x, and inverse R multiply with Q transpose and multiply with B, we get 3 value also, which is 1.51986, negative 1.10846, and 1.07096. And then we insert the command and transpose QT multiply with R, and this, as you can see here, we get a 3x4 matrix. And then we insert the command QQ equal to transpose orthogonalize transpose M. After we insert the command QQ, the output will come out, and this is the matrix of QQ. And then we insert the command RR equal to N transpose QQ multiply with M. And as you can see, this is the output of RR that we get from the Mathematica. So we want to get the value of x, we insert command x equal to N inverse RR multiply with transpose QQ multiply with B, and the output will come out as the value of x, which is 1.51986, negative 1.10856, and 1.0716. And that's all from me. Thank you.